we're going to look at how we can write an equation in factored form when given a polynomial graph. So all of the key features that we've needed before, such as end behavior, intercepts, degree, multiplicity, all that's still going to come into play here. So over here, I've created a box of information that we're going to look for. So let's start with the leading coefficient. Is it positive or negative? I'm going to determine that by looking at my right-hand side. Because my right-hand side is traveling down, I know that my leading coefficient has to be a negative number. So I'm going to come back to that later, but I go ahead and have that information. Then, looking at the other side of my end behavior, knowing that my ends, one side's going down, one side's going up, so they're going in opposite directions, means that my degree needs to be an odd number. When I check out my multiplicities later, I'm going to make sure that they do indeed add up to give me an odd number. So now I can look at my zeros. Those are going to be some of the most important parts of my graph because my zeros give me my factors. I have one here at -3. And because it has this squiggle shape, or it kind of looks cubic just right here, I know that not only do I have a 0 at -3, it has a multiplicity of 3. So I'm going to go ahead and write that in. I have a 0 at -3, 0. And the multiplicity is 3 because it has that kind of a weird squiggle shape. I'm going to follow and I cross the x-axis again here at 2. So I have a 0 at 2. And once again, if we look at its behavior, notice it touches the x-axis and then turns around. So it almost looks, if I were just looking at this bit here, it almost looks a little quadratic. And so that means that I have this factor twice. It has a multiplicity of 2. And we just had an extra box. Didn't need that, but always good enough. So now we can go ahead and keep going. We have some really great parts right now. The only other part I have is the y-intercept. And this is what's going to take it from just a possible equation to the equation we are confident in. And this one, my y-intercept is going to be at 0, -3. So now we're ready to write our equation. There's going to be a little figuring out that we have to do. The first thing I'm going to do is I'm going to write what I consider the possible equation. You could use f of x or y, doesn't matter. Equals, it has a negative leading coefficient, so I'm going to write a negative. We're going to use a placeholder of a for our actual leading coefficient to determine what the value is going to be here. And then we can go ahead and put in our factors and their exponents. So the factor that gives me -3 is x plus 3. And has a multiplicity of 3, so it's cubed. And then the factor that gives me x equals 2 is x minus 2. And it has a multiplicity of 2, so we're going to make that squared. So far, my equation takes into consideration my degree. It's odd. 3 plus 2 is 5. That's an odd number. My negative leading coefficient. It has my zeros, the other factors, and their multiplicities. This a part comes into terms when we talk about our y-intercept. And so we know for our y-intercept, our x value is 0 and our y value is -3. So I'm going to make that substitution in here. I'm going to say -3 equals -a, 0 plus 3 cubed, 0 minus 2 squared. So I substituted in this coordinate to help me find out what is the value of a. Oftentimes, this will end up being like 2, 4, or even maybe a fraction. We'll see a lot of fractions to kind of make some of these very large numbers a little bit smaller. So now we have enough information to actually work out what is our a value, what is actually our leading coefficient. So I'm going to do some simplifying here. This becomes 3 cubed, and this becomes -2 squared. Notice that I have a negative here and a negative here, so I'm just going to divide by that negative to get rid of it. That's going to help me out a little bit. So I have 3 equals a times, well, 3 cubed is 27, and -2 squared is 4. Without a calculator, 27 times 4 is going to be kind of big. I do know that 27 times 4 is, I'm sorry, 27 times 2 is 54. So I know that this probably ends up being 108, but if I'm looking at this being like, I don't want to do that, I know that 3 can divide into 27. So that's actually what I'm going to do here just to make it a little bit easier. So I'm going to divide out this 3. That gives me 1 equals A. 27 divided by 3 is 9. And we already did the division there, so I'm not going to simplify anything else. Now, 9 times 4 is 36. To get A by itself, I'm going to divide by the 36. So A is equal to 1 over 36. So that is going to be my kind of factor at the front. That is going to be my leading coefficient. I can substitute this in here, and I have my full equation. So I can say my equation is f of x equals, it was originally negative, so negative 1 over 36, x plus 3 cubed, x minus 2 squared. And if you go put this into a graphing utility such as Desmos, this is the graph that you should get out, and you could double check this point here. So while you are in that practicing stage and you have access to technology, it's always really useful to throw in your equation into some sort of graphing utility and double check that you are getting the equation out. If you're not getting the same graph, that just means that you need to make some tweaks. You need to go and see where your mistake is. To step you through this just one last time, I put an A here as a placeholder for my leading coefficient. I substituted in my y-intercept, so I made y negative 3 and my zeros x's. And then I just solved out for my A value. I started by getting rid of that negative. And then here, once again, I could have done 27 by 4 and then 3 divided by that. It seemed a little bit harder in my mind. So I divided by 3. So 3 divided by 3 is 1. 27 divided by 3 was 9. And just finished solving out. And that is what you plug in here for your A term. And this is how you can write an equation in factored form. If for any reason you were asked to then put this into standard form, you would just multiply all of these out using whichever method you use, such as the box method. So x plus 3 times x plus 3 times x plus 3, etc. All right.